Hello everyone, in this video I am going to discuss this nice problem on Fibonacci sequence from the book Math Storm. And in this problem you are given the Fibonacci sequence for which f naught equals to 1, f1 equals to 1, and the recurrence relation for Fibonacci sequence is f of n equals to f of n minus 1 plus f of n minus 2 for n greater than equal to 2. And now you have to show that 31 fn plus 2 raised to the power 5 minus fn raised to the power 5 minus f of n plus 1 raised to the power 5 is divisible by f of n plus 3. Okay, so what can I write? The given expression 31 times fn plus 2 raised to the power 5 minus fn raised to the power 5 f of n plus 1 raised to the power 5. We can write this expression as 31 times f of n plus 2 raised to the power 5 plus 31 times f of n plus 1 raised to the power 5 minus fn raised to the power 5 plus 32 times f of n plus 1 raised to the power 5. Actually, we have add and subtract this term 31 f of n plus 1 raised to the power 5. Okay, so we can take 31 common from the first bracket. F of n plus 2 raised to the power 5 plus f of n plus 1 raised to the power 5 minus fn raised to the power 5 plus 2 fn plus 1 raised to the power 5. Yeah, okay. And we are familiar with the factors of x to the power 5 plus y to the power 5, and clearly the factors are x plus y, factors are x plus y, x to the power 4 minus x qy minus x qy plus x square y square minus x y cube plus y raised to the power 4. So if we factorize both the expression, then we can write the factors as f of n plus 2 plus f of n plus 1. This is the first factor. And what about the second factor? Fn plus 2 raised to the power 4 minus fn plus 2 whole cube into f of n plus 1 plus f of n plus 2 whole square into f of n plus 1 whole square minus f of n plus 2 into f of n plus 1 whole cube plus last term is f of n plus 1 raised to the power 4. Similarly, we can factorize the second term. The factors are clearly x plus y. Here y is what? 2 times fn plus 1. Fn plus 2 times fn plus 1. This is the first factor. And what is the second factor? Fn raised to the power 4 minus fn raised to the power 4 into 2 times fn plus 1. So we can write 2 fn raised to the power 4 into fn plus 1 plus fn, sorry, here it is fn raised to the power 3. And the next term is fn square into 2fn plus 1 whole square. So it takes the form fn square into fn plus 1 whole square. The next term is minus fn into 2fn plus 1 whole cube. So we can write it 8 times fn into fn plus 1 whole cube. And what is the last term? 16 f of n plus 1 raised to the power 4. Okay, there's a first equation. Now look at this term using the definition of Fibonacci sequence, using the recurrence relation of Fibonacci sequence. F of n plus 2 plus f of n plus 1 becomes what? This becomes clearly f of n plus 3. Also I am going to work on this factor as well. F of n plus 2 times f of n plus 1 can be written as f of n plus f of n plus 1 plus f of n plus 1, and this sum becomes what? This sum becomes f of n plus 2 plus f of n plus 1, and f of n plus 2 plus f of n plus 1 becomes what? F of n plus 3. Therefore 1 will imply 31 fn plus 2 raised to the power 5 minus fn raised to the power 5 minus fn plus 1 raised to the power 5 equals to 31 times f of n plus 3 into f of n plus 2 raised to the power 4 minus f of n plus 2 whole cube times fn plus 1 plus f of n plus 2 whole square, f of n plus 1 whole square minus f of n plus 2 into f of n plus 1 whole cube plus f of n plus 1 whole 4. And the second factor also becomes what? F of n plus 3 into this whole factor. We can copy paste this factor. This factor is as it is. Okay, now you can see the right hand side. There is a difference of two terms, and each term contains the factor f of n plus 3. So we can say that f of n plus 3 divides 31 times fn plus 2 raised to the power 5 minus fn raised to the power 5 minus f of n plus 1 raised to the power 5. That is, f of n plus 3 becomes the factor of this, and hence proved. Thanks for watching.